Hello again and welcome back to another devlog. Today is primarily going to be focused on the saving and loading mechanisms so that the player's progress through the levels isn't lost between launches of the game, and also things like settings, customizations and whatever other features might be introduced further down the line can persist between these sessions. I'm going to start off the episode with a quick improvement I mentioned in the last, which was to have each particle in the flame produce the light as opposed to just one static point light on the torch. To accomplish this, it's normally possible to attach lights directly to a particle system, however as I'm using the experimental 2D lights from the URP, it wasn't quite as simple as that. Fortunately, I came across a script on the Unity forums which accomplishes exactly that, and I've linked this in the description. All I needed to do was add this to the same object my particle system is attached to, and create a 2D point light prefab for the use of each particle. I also want the torch flame to be smaller than the start and finish ones, so I added a simple script to manage some of the emissions settings dependent on the tags of the game object it is attached to. This means the emission settings can differ between each flame while still using the same prefab. The end result of those changes can be seen here, and I'll overlay the previous setup side by side. I think it's a definite improvement, especially when it comes to the light moving a bit more naturally as the torch moves across the screen and the particles start to lag behind a bit, but let me know what you think in the comments. Now let's get going on the save system. I referenced Brackey's video on this as an example of how to save down data in binary within Unity, which as ever will be linked in the description. I started things off by reformatting my level class. I made it serializable so that 5 core attributes of world number, level number, time, rating and their unlock status could be written to and read from binary. I also added an additional constructor to be used in the load level method, which I'll talk about in a bit more detail shortly. I then created a new class, save system, and wrote 2 methods of save level and load level. The save level method takes in the level object we just saw as a parameter, and we use the binary formatter to save this data to a file, which will then be named as its level name and appended with .dat. We write this file and then close the string. In load level, we attempt to load the file if one has been saved down. If it exists, we'll read the file and deserialize it back into a level object, and if not, we'll simply create a new one. In this case, when the new level was created, its unlock status is set to false unless it's the first level of the world, and then it's given a default best time and ratings of 0. In the level manager, we are now calling load level for each level after fetching them in the same way as we did previously, which is by using the scenes included in the build. On finishing a level, we check if our previous best time is 0, meaning it hasn't yet been completed, or if it's slower than the new time we just achieved, and if so, we update the best time attribute before saving this back down. We also need to create a new save file for the next level if one exists, so that it becomes unlocked to the player. Let's take a look at this system in action. The first thing you'll notice when we enter the game and take a look at the level selector is that we can now see that the levels which are locked will display a padlock symbol instead of the information about the level. If we click on those, nothing will happen. On the right hand side of my screen you can see the folder that Unity saves project specific data into, which is currently empty. If we then go ahead and complete our first level, we'll see that 2 files have been created in this directory, 1.1 and 1.2. The 1.1 file has been saved to store down things like the time, whereas the 1.2 file has been saved just so it's unlocked for the player. So if we now go back to the main menu, we can see that firstly our time of 3.9 seconds has been saved as our best time for level 1, and level 2 has now become available to play. If we go back into level 1 and beat our previous best time, we can also see that this is reflected on returning back to the main menu. If we were to replay this and fail to beat our best time, then this isn't updated to the latest, but will continue to store and display the current record instead. I think one of the benefits of this system is that it should prevent external tampering, or at least make it a bit more challenging. Even with the files being written to binary, it's still possible to parse these back to a standard config file and update values such as unlocked to true, and progress that way instead of actually through the gameplay. By not even generating the level data until the level is first unlocked, this essentially should avoid this exploit entirely. If I eventually end up implementing some sort of online leaderboard, which has crossed my mind, then some more effort will need to go into locking these files away so that things like the time can't be tampered with, but we'll address this issue if and when it arises. There's one more component I wanted to make a start on today, and that's customization. As a player progresses through the game, either through regular level completion, perhaps a collection of some coins or a currency, or maybe through some special challenges, I want them to be rewarded with some customization options. Initially, my ideas are to be able to customize the colour of the flame and maybe the actual body of the torch itself. To start off with, I made a new menu accessible through the main menu, which I've called Customize. In here, there are some text elements for what you're customizing or to leave the menu. There's also a scroll view, so if the customization options extend beyond the space on the screen, the player can scroll to view the other options. I've got a prototype all hooked up, so let's do a demo before talking through how everything works under the hood. When we load into the game, we're greeted by a familiar view, but let's open the customization menu. Immediately, you'll be able to see a whole bunch of options the player can select for what the torch looks like. The visual for each of these options are all the exact same particle system which is present on the torch itself, but tinted with different gradients. For now, these gradients can be created in the Unity editor through a serializable array in a flame color script. Each of these flame gradients has a name, gradient, and unlocked status. As you can see, when these are set to be locked and the player visits the customization menu, these will be blacked out and unclickable. For those which are unlocked, clicking them will result in the flame color being set to the gradient you've clicked on. The light emitted from the torch will also be adjusted to match that color. If we then start a level, we can see that all the various flame objects in the level, including the torch itself, the star, and the goals, will all take on these same gradients. The player can change their color at any time by revisiting the customization menu, and most importantly, their changes are also persisted between their game sessions. Now let's talk about how this all works under the hood, starting with the customization menu class attached to the UI itself. You may have noticed that when we enter the menu, the camera zooms a bit closer to the torch so the player is able to more clearly focus on what is being changed. This is done through a cinemachine transition between two virtual cameras, which is initiated by upping the priority on the store cam in the onEnable method. The priority is reduced back down when we call the back method to return to the main menu. Now, for displaying the available gradients to the user, we loop through all of the flame gradients that we can find from the flame color script, which is attached to a new singleton object named Preferences Manager. This will eventually be used to manage all of the player's settings, such as their volumes, their resolution, and of course their customizations. We instantiate a new instance of the flame prefab into each box, and then check if the current gradient is unlocked. If it is, we'll set the color of the flame using the gradient settings and a delegate method to activate on click. However, if it's locked, we'll just set the gradient to a pure black. The delegate to set the flame as active does two things. Firstly, it actually modifies the visual appearance of the torch on the main menu by setting the particle system's gradient and associated light 2D to the correct colors. And secondly, it will call setActiveFlameGradient in the Preferences Manager, which will find the index of the flame gradient object and save this into the player data. The saving and loading of the player data is functionally very similar to that of the level data. It's a serializable class which is converted to and from binary in the exact same way. Now, to manage the gradients a player can unlock and select, as previously mentioned, this is currently just handled within the editor itself. The Preferences Manager game object has a basic flame color script attached to it, with the only purpose of this being to display a serializable field of an array of flame gradient objects. Making it a serializable field in this way means I can then add to it just through the editor. So if I wanted to add a new gradient, all I have to do is click on this plus icon, enter a name, and then choose some color keys to decide what it's going to look like. Let's just select some random color keys here for now, set it to be unlocked, and restart the game. As you can see, at the end of our customization menu, we can now see the new gradient that we just created. It looks terrible, but you get the idea. It's very easy to add new gradients as and when I want to. Just to mention how the lighting color works, currently this is just a static color, which is taken by guessing the average color key of the gradient. It's not a perfect solution, especially for more complicated gradients with lots of color keys like the rainbow example I made, but it will do for now. Right, that's all I've got time for this week, but I think we're edging closer to having enough gameplay components in place to start just building out some levels and thinking of some new challenges to be implemented. Before this, I expect next time we'll polish up some of the movement, because currently controlling the player is just unnecessarily clunky and difficult, and we also need to get some music or at least some sound effects in place. As always, thank you so much for watching. If you enjoyed the video, please don't forget to drop a thumbs up and subscribe to make sure you don't miss out on future episodes. And if you have any recommendations or things you'd like to see in future episodes, then please feel free to drop them in the comments. It's always great getting feedback on things I can improve on. So thanks again, and until next time, take care.